So, fun fact, most cameras used in space can't actually do this. Instead, astronomers have to predict what sort of light levels that the camera is going to be imaging and try to plan ahead so that the aperture is the correct size for the exact target that the scientists behind the project are expecting to encounter. This poses problems for certain spacecraft that are tasked with imaging multiple objects in the same mission. So a good example of this would be OSIRIS-REx. Its MapCam was designed to study the limited color palette, so to speak, I guess, of an asteroid. So when it was used to take a picture of the Earth, it had all these artifacts at the top of the image. The camera was basically overwhelmed by the bright light reflecting off of the Earth's clouds. But when you look at the images that it snapped of Bennu, everything looks fine. It's a little dark, but it looks fine. And that's because it was specifically designed to image this one asteroid. So time is another factor. In photography, longer exposures allow cameras to take in more light, right? This allows the camera to pick up things that don't emit as much light that a shorter exposure simply wouldn't pick up. Astronomers kind of do this when they go out into the field and, to look up in the night sky and study it, right? Well, in a way, at least. A longer exposure is kind of similar to letting your eyes adjust to the dark for like 30 minutes, I think is what they suggest, usually. Human eyes don't really have exposure settings, but this is, I guess, the closest thing we have to it. But here's the important thing. Short exposures can't capture stars. So talking about the Apollo program, the cameras used during the Apollo missions were designed to image the lunar surface. Have you ever seen the full moon? I know you have, right?
I think we had one the other night.
Yeah, it was the other night, right? It's bright as hell in my telescope, too. And I have this crappy department store telescope, and I'm actually writing a script that's going to be covering basics for amateur astronomy, too, because I've had to learn some things the hard way. But yeah, it's super bright. And so the cameras that were designed for the Apollo program were designed for that light environment, that bright light shining on the lunar surface. I mean, the astronauts weren't playing around in, on the far side of the moon or in the night areas of the moon, so to speak, right? So that's why you can't see stars in any of that footage or any of those photographs. The cameras simply weren't built for the exposure that would require.
Yeah, I mean, that makes sense, especially when you consider that all the pictures that they were taking was stuff that was in the general vicinity of the cameras. They weren't trying to take pictures of the night sky from the moon. They were trying to take pictures of the moon.
Right, but even if they were to point those cameras at the stars, it's highly unlikely that they would have been able to image anything other than black sky.
Oh yeah, it's like you said, the lensing was calibrated for a certain kind of...
Right, the aperture.
Okay.
Right. So when these people complain about this, it's absolutely stupid because they don't understand how cameras